Cool. Well, Rajesh, good to see you again.
Good to see you, Pete.
When was the last time I saw you? Was it in Embedded World?
Embedded World, yeah.
Not too long ago. Feels like
2 weeks ago, yeah.
the whole first few months of this year is like between CES and Embedded World and Austin. We had that thing in Austin. It was kind of like nonstop. Now I feel like it's pump the brakes a little bit, which is good.
Yeah. And before you even think about it, it's going to be July.
I know. Yeah, well, we have our Milan event in July, which I've already booked my tickets for. So it's like, a year's half over. But anyway. But yeah, good to see you. And you're are you dialing in from California, or where are you?
Yes, I'm back. I'm home at California. I'm actually dialing in from San Ramon.
Fantastic. Yes, I'm in Bellevue, Washington here. Nice and rainy.
Perfect. So that's good. Yeah, it's been raining the last couple of days. So it was sunny 3 days ago, but now it's
a good thing.
Really.
So EmbedUR. So, one of the reasons we do this is we have lots of different partners in the foundation. Some of them are super well known, some of them not as well known. A lot of folks know who EmbedUR is, but maybe some people don't. So I wanted to kind of just talk to you and kind of let people know what EmbedUR is up to, what you're up to, and let the audience know what's happening.
Yeah, thank you again, Pete. Thanks for taking the time to do this.
Sure.
Well, primarily, I started the company in 2004, and the goal was to build embedded software for some of our customers and provide embedded engineering as a service to some of our customers so they can bring embedded products to market faster. Now, over the years, we started off as a highly experienced connectivity team, and meaning working on Bluetooth and Wi-Fi. And then we pivoted towards IoT, so building IoT software. And then in the last 4 or 5 years, it's been talk about artificial intelligence. And then how do we pivot that intelligence and take it to the edge and move it to smaller devices where we have the embedded skills, but bringing intelligence to embedded devices is a whole completely different ballgame. And that's what we've been engaged in the last 4 or 5 years and last 3 years. And again, thanks to the Edge AI Foundation, we've been able to work more closely with your teams and progress and work with some of the partners in the group to advance their product deployment opportunities.
Yeah. I think there's an interesting skill gap, between embedded developers. I used to be an embedded developer, BIOS and stuff. And then there's AI engineers, right? Maybe they typically kind of working in Python and sort of they're up here, and embedded folks are down here. And so it must have been an interesting challenge for you guys to sort of, how do you combine those skills together? Hire people, or did you hire people that had the skills, or you trained them up, or what was the?
So we took a 3-pillar approach, right? First, retool our engineers to think bigger in terms of understanding what is intelligence, number one.
Yeah.
Then we went and brought in data scientists who can analyze data. And then we brought these two together with coaching. So basically, took the technology, took the team. It was a lot of coaching and bringing them together. And if you think about what's happened in the last 4 years to 5 or 6 years, in my opinion, we went all the way from desktops to cloud, right? And then AWS, Azure, Google Cloud, Oracle, all these became really, really popular. And then there was a huge, if you look at education and students graduating from computer science, they were all about, I want to go work on the cloud because that's the coolest thing. Sure. And I want to do cloud compute. I want to build DevOps for the cloud. So that became a thing. But in the process, the embedded software piece was getting very less attention. And as a result, not many embedded engineers were out there, experienced ones. And even kids getting out of school didn't want to go do embedded because, what is embedded? I would rather do cloud.
Sure.
And then now we've seen the whole thing. Like we went from servers, then we went to desktops, then we said, no, we went to cloud. If you think about the whole edge piece, now we are coming back to the edge, saying, okay, edge is still important. And now if you're at the edge and for smaller devices and day-to-day devices, wearables and, devices at home, industrial automation, devices for industrial automation, they all need edge software and embedded software.
Right.
So we are in a great place right now where we're finding a lot of customers coming and asking us, hey, really, this embedded engineering skill is becoming important. And on top of that, the idea of edge intelligence and artificial intelligence for the edge is becoming important. So we're kind of in a sweet spot is what we're finding.
Yeah. No, it's interesting because I think as software developers, people are attracted to the cloud because the last thing a software developer wants is hardware to get in the way of their code.
Exactly.
And
Exactly.
the cloud is nice because it's all virtualized. You don't even know what hardware you're running on. But when you get into embedded devices, you need to be at one with the hardware, right?
Yeah, and again, right? When I went to school, I was coding with microprocessors, right? I mean, how many
Right.
kids code with microprocessors these days? Very less, right? I mean, you need to know assembly language, right?
Mm-hmm.
And you need to know what your RAM is, what your flash is, how do you optimize
Sure.
memory, how do you optimize power? All that is becoming more and more important.
Sure.
And if you again think about this, this is mind blowing, right? I mean, I was it was Taiwan,
Mm-hmm.
Taipei at the Edge AI summit last year.
Mm-hmm.
So these guys approached us, and you know what they're building? They're building power stabilizers. Okay,
Mm.
in a power stabilizer, there's no active component, right? It's all passive. Now
Right.
these guys were thinking of putting I think an ST micro, one of the silicon vendors chips with an NPU on it.
Mm.
Now, the moment you put an NPU on it, and
Mm.
and upgrade your microcontroller with an NPU, it's a whole different ballgame. All of a sudden they need software.
Yeah.
So it's getting to a point where if you're building anything, you will need software going forward. So every
Yeah.
company has to transition into a software company as well.
True, true. Yeah, every company is becoming a tech company, and every company is becoming a software company.
Software.
Even we had Procter and Gamble on. I mean, I use their toothbrush, and there's lots of
Yeah.
software in that toothbrush.
It's crazy
Uh,
amount of software, right? Yeah.
yeah. So no, and I know you guys had. Speaking of embedded world, you had a pretty cool booth there, and it was packed with
Thank you. Yes.
demos. It was like the Disneyland of Edge
It
AI
was,
demos in there.
yeah, it
What were
was
some of your favorite? What were some of your favorite examples of your
some of the
projects?
most favorite ones that was we did one on audio denoising with the model, right?
Hmm.
On an ST micro. That was just mind blowing. We had so many customers, potential customers, stop by, and
Right.
ST
Right.
themselves stopped by multiple times. And this is a game changer because you can now build these headsets at low cost without having to have a DSP in it, with just an
Hmm.
audio codec and a model. You think about it,
Right.
it's like just completely different.
Yeah.
And the use cases are just so many, right? I mean, hard
Mhm.
hats, people working in aviation,
Mhm.
people on a motorbike, and so
Right.
that was pretty cool because you can still hear
Yeah.
ambient noise,
Right.
like it will suppress the background noise, but I can still hear everybody else talking.
Yeah. Yeah,
Um,
that's amazing. And speaking of audio, we have a new audio AI working group, and one of the cool things about audio AI is that you can use audio to detect things like in a room without
yeah,
using cameras, right? So you
yeah.
can hear things. You can hear, or in your wildlife or environmental monitoring, for example, you can hear birds. You can
Oh, yeah. You
distinguish a number of birds, bugs. You can hear. So this audio thing, which kind of was like not as cool, is now like the new thing because you can do all kinds of environmental detection or spatial detection even with audio, especially like gunshot detection, glass breaking detection, all kinds of stuff. So it's now become like the hot thing, audio AI, which is kind of cool.
Absolutely. And the
Yeah.
next cool thing that we demonstrated through one of our partners, Synaptics, is the sensor. It's a privacy sensor, but it's
Hmm.
not really a camera. But
Yeah.
you can look at it; it just sketches your outline of your face,
Hmm.
and then you can register with it. And the moment you register, it knows it's you. So then you can control. We show a person controlling lighting. So as soon as
Hmm.
like I register and I choose yellow to be my color, and then somebody else comes and they choose blue, it recognizes and changes the color of the light, right? I mean, wide
Hmm.
ranging applications where you can go to your coffee machine, and there's a video we did about that where
Right.
if you incorporate this in the day-to-day coffee machine, it knows
I
how to
see.
set the grind level, temperature level, and how many
So
shots
it
you
does it sort of does a detection based on like radio waves, or it's not a camera, or is it visual?
it is sort of a camera. We call it a privacy sensor. It
Hmm.
still gets your face, but it
Right.
actually doesn't register your face as
The
such.
picture. Yeah. That's pretty
Yeah.
cool.
Yeah, and
Yeah.
and so that way you don't have to worry that it's like a full blown camera that's like looking at you all the
Right.
time. So it's really
Yeah.
not.
That's actually a
And
big issue with privacy these days. People don't
yeah,
want to use cameras, but they do want to know like how many people are in the room or how long are they there and what's happening. And
and that's another application for it, and it particularly becomes very important in Europe where GDPR is very prevalent,
mm,
right? I mean, they're very
yeah,
very sensitive about no, are you registering? Is this in the database? No, none of that stuff, right?
I
It's
see.
just facial contours that are being mapped back to the model, and then it knows, and that's all it knows. There's,
Oh,
there's nothing else. And the cool thing about it is you can register up to 250 people in a small amount of memory without connectivity back to the cloud, which is completely, so nobody can hack into your coffee machine now, right? You don't need Bluetooth connectivity, right? I mean, or your thermostat for that matter, or your doorbell camera for that matter. So unbelievable applications.
Yeah.
And then we did one, which was a huge hit with our partner, ST Micro. We did facial recognition and image segmentation models running. We had 3 models running on it, where you could, again, register yourself, and it'll still recognize you. Plus, it will also do image segmentation to figure out how many people are in the room. So it's like something that you can use in a conference room. And that was very well accepted. And now we're getting a lot of requests. In fact, I was in a meeting with the head of AI strategy, Miguel, from ST Micro, and he was pretty impressed. And so they've named us as one of a premium partner because we did all of this without any help from ST Micro, and they were pretty impressed with that.
Well, that's good. So when you guys do these projects, I mean, you're doing it sort of soup to nuts because you've got experience with, the connectivity you mentioned and the MCUs and the MPUs. And so do you do design, help do hardware design as well as the software implementation, or what's your...
So we announced Model Nova in Milan last year.
Right.
So Model Nova is, and that's something, again, thanks, that we've also kind of extended to Edge AI Labs. And if you think about what we are doing today is we are going out there and picking up models, and some models we are building ourselves and actually pushing it out to Model Nova. And then we're optimizing the hell out of the model. So that way you get accuracies of 96%. It's still not good enough for productization, but it's great for you to try
pretty close
to a small mini POC. And then our goal is that, potential customers who are either chip vendors or their customers can come in and use Model Nova. And let's say they have a specific application. They can go pick one of those models and try a POC on a Raspberry Pi or whatever. And then once they're happy with it, then it's now taking it from 96% to 99% in terms of model accuracy, number one.
Right.
And number two, maybe it becomes a question of retraining the model and giving them the same accuracy. Third step is move that model to a chip of their choice. Maybe it's a Synaptics chip. Maybe it's a NXP chip. So we do all of this for our customers.
I see.
And that's where we bring a lot of value, because we've already kind of done the groundwork. And again, and you talked about this as well. This was, again, at Embedded World, where you had that panel discussion with Edge Impulse and a whole bunch of people.
Yeah.
One of the biggest issues we are finding is data sets, right? Your model is only as good as your data set. And that's where we are working really hard to curate the data set. Because if you don't curate the data set, junk data means junk model.
Yeah,
and that's the biggest value. And now take that model and optimize it completely, which is our next biggest strength, to low cost, low power environments.
Right.
So,
interesting. Yeah, I think it's interesting you mentioned that commercialization aspect is kind of like the secret sauce. Lots of people can kind of stitch some stuff together and get something working, but to actually bring it all the way through and optimize it, wring out all the bugs and the sustainability, the updatability.
So this privacy sensor I was talking about, Pete, you believe it or not, we've been testing it for 6 months. You would think it's a simple thing, right?
Right.
But the problem is, it's like, ambient lighting, dark room, blinds on, blinds off, different types of people, different aspects of the communities of people across the world, right? Because this has to work world over.
Right.
And so it needs to be able to recognize all sorts of people in terms of lighting, in terms of, posturing, whatever it is.
Conditions, right.
Yeah. And it was so hard to even get to 98%. And so the two big challenges, right, in this whole, it's all great to have an NPU. The two big challenges that we are finding: curating the right data set, and then getting 99% model accuracy.
Yeah. Tuning it. Yeah, like you said, there's a huge leap. A lot of people don't realize when they go see a demo. Usually that's a pretty controlled demo, and it's like, like you said, the lighting is a certain way and blah, 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 but to actually ship it, it, and that's where you guys come in, is to help companies actually ship stuff.
Exactly.
Which is again that whole stack. We talk about the stack of edge AI from metal to cloud. You know, everyone plays a role. Some people make chips, some people make models, whatever. But the solution provider, the person that
Bringing it
stitches it together and commercializes it, kind of like the critical. That's in the critical path. So that's what you guys do.
That's so mission critical. That's where we come in.
Yeah.
We actually make it real. We really make it real.
Cool. And so are you a worldwide kind of, you doing work worldwide now, or do you have particular regions of focus, or what are the hot
Worldwide.
industries or the hot geos?
Worldwide, Pete. And that's I mean, I have to thank the Edge AI Foundation for that, right? And then becoming active leaders and trying to participate and understanding the ecosystem was the first big eye opener, right?
Yeah.
And that led to a whole bunch of partnerships.
Right.
So now, because of the partnerships, we are working with, I'll give you an example. We showed demos with NXP at Embedded World. We showed demos with Synaptics. We showed demos with Infineon. We showed demos with ST Micro.
Wow.
Now, all of them. And we also showed some demos with Silicon Labs, though it was not available for public viewing. It was very specific to them. And so as a result, they cater to the entire world.
Yeah.
Now this has opened us up to, we believe, an abundance in terms of opportunity that we now need to evaluate and make sure that we go after the best ones that make a bigger impact for the world and the community and for us.
Sure. Yeah. Well, it sounds like more miles on the airplane than maybe a little bit.
Yeah. Which is always fun.
That's true. Yeah. We tend to meet up in anywhere but our home locations, right?
Exactly.
Yeah. Cool. Well, Rajesh, this has been great. I think people getting an interesting, good picture of EmbedUR and what's happening. And, people that come to Milan in July 2nd through 4th, we'll see you there, I'm sure. And
we're super excited about Milan.
More demos, and
we're doing something completely different, Pete. So this is going to be pretty cool. It's going to be.
You guys always have like the top end, like for folks that don't know, it always looks really good. You always have the demos. You always have the stuff is working really nice.
Thank you. We have an awesome team. These guys, Eric, John, Sai, and the rest of the team, engineering team. They're all excited about this. So it's going to be fun. It's going to be completely different.
Good. Sounds good. All right, Rajesh. Well, I'm sure I'll see you before then, but thanks for your time today.
Thank you, Pete. Thanks for your time as well.